Okay, we want to use a different directory. We want to use the ctemp directory that I just created. So we're going to change the directory. I'm going to set the directory to ctemp. And to do that, you just say, to do it with a command. I'll show you the command way and then the easy way. You just say set working directory, parentheses. You need to use quotes. Quote, got to have the parentheses in the right direction. Capital C, colon, / not backslash, temp. So if I do this, note we're using, this is contrary to the Windows, I'm on a Windows machine. This is contrary to the Windows syntax. A backslash in R is an escape character. It has a special meaning that we'll see. So even though the correct syntax for the path directory in Windows is a backslash, R, you use a single / or even a double /, either way will work just fine. And so if I do this, and then we say, what is the directory now? Get working directory. You'll see that it's been changed. Now it's ctemp. So now you can see, if you want to see what files you have, and again, it's going to look in the default directory unless I tell it otherwise. You can use the list files command, list files function. Note dot is not special in R. You can use a period in a file name just fine, which is unique to R and some other languages. It's helpful as well. So list files, if I say list files, it shows me all of the files that are in my default directory, and there are a bunch of them. Now, let's look at this file ZR. I have it right here. Here's ZR. This is our first program. It generates a graph. And you may have figured out already with R, the # is a comment delimiter. The interpreter, whenever it sees a #, it ignores everything after it. So you can annotate your text and do whatever you want. So here's our program. It's just these 3 simple commands. First command is PDF. We're telling it to, we're calling the PDF function, and it tells R, the graph that I save, I want you to put it in a PDF file with this name. This is not created yet, but I'm telling it I'm going to create a PDF. It's just identifying the name of the graphical output file. And then I'm going to draw a plot, a histogram, using R norm, just calling 100 numbers of R norm. That will be a normally distributed random variable with a mean of 0 if I don't tell it otherwise, and a standard deviation of 1, and it'll draw a histogram. A histogram looks like this, of course. Here's a histogram. It's a density plot. It shows frequency. Histograms are one of the few plots that plot just simply one variable. So here's our data set. These are the values of R norm, and you see the mean is somewhere. It's not a mean actually. It's a mode, and this is non-parametric, so it's a mode. It's close to 0, somewhere around 0, and but we're going to create a PDF out of this, and then we're going to store it in this file, XHPDF. And whenever you do this, whenever you call one of the graphical functions and you save it, what we're really doing, we're not saving it, we're sending it to the default graphical device, which we've just opened up here. We've set the graphical device to be a PDF file, which means whatever graphic we create next is going to be sent to this thing. In order to actually write it to disk, we need to turn it off. You always have to say dev.off to close the graphical output file. And that actually writes it to disk. So anyway, our command, our file, z.r, just consists of these three commands. PDF, it doesn't even have the get or the set. It's just these three: PDF, hist.norm, and dev.off. Okay, so I'm going to call it just like this. I'm just going to say source and call the file, which is in the default directory. So I do that, and it didn't like it for some reason, because we needed to set the directory properly, and we did. And then so now I call it, and it should work just fine. I copied it into it a minute ago. And why isn't it liking this? Okay, it's embarrassing. Let me show you another way to set the directory. You come up here and you can just say Tools, Set Working Directory. You can do this in RStudio. Choose Directory. And there it is, temp. Okay, so temp is the directory. Say yes. And oh, I know why. Because actually in the file, I believe I have these other commands. I do. Let me grab it quickly. Open up Notepad. Go down here, find it on C, and where the heck is it? Okay, let's do this. Sure, I copied it in there. Okay, let me get rid of this. And there it is, ZR. I'll say File, Save As. Z.R. Already exists. Yes. Okay, and now I'm going to call it, and hopefully it won't embarrass me. Source it. There we go. And so it ran. So now let's go down and look and see what files we have down there. And sure enough, here's our PDF XH. Pop that open. Take a look at it. And there's our histogram. So we created this, it saved it. Note it looks a little different than the one I just ran because it's going to be a different data set. So we just created a PDF and stored it on disk. Okay. So let's do, now if we say list files, we could do that. You could also use the command, let's see, the name of it was XH, there it is. We could use the command file exists, which returns a true false. We could say file.exists xh.pdf true. So it goes down there and checks the directory and sees if that file is there, and if it is, it returns a true. So there's a lot of things you can do to interactively look at files in the different directories on the path. However, that's not what we're talking about. We're talking about batch, doing things in a batch. Okay, let's look at a couple of very common commands in script. Any questions or comments anybody wants to make? Now, you can see, here's my workspace, nothing in it. You can always check what's in your workspace. Let's say a few words about this, okay? I'm assuming everybody knows what the workspace is, and you might not. R has kind of a unique working architecture. Some people consider this to be limiting, but if you're very forward-looking, you might describe it as being advanced. And that is, in a session is when you actually start R up and begin to run commands. A session is actually held in place by it occurs in memory. It's everything is executing in memory. That is, every time you create a variable, every time you load a data set, every time you create a function or call a function, it's not paging them on and off the disk. It's loading them into the memory and holding them there in the memory. The session is electronic, literally. Even large data files, when you call in a large data file, it calls the entire thing into memory. Now, when I say that, you'll immediately think, well, wait a minute, in this day and age, we're talking about big data. We're talking about terabytes of data in files. That's not going to work because desktop computers aren't big enough yet. And that's true. So you do have this problem with R when you're using really large data sets that people are addressing now, and there are some solutions. How you actively rehearse the data in memory, how do you maintain the data in your session with the size limitations, okay? And so we'll come back to that. But on the other hand, if you look at how the technology is developing, memory is getting larger and larger, it's quite possible that problem will be overcome by the technology before too long. So in that sense, you might say they were forward-looking. But at the moment, it's still a problem. Okay, the session, your workspace, think of your workspace as a bucket, as an electronic bucket. And everything you use and create gets tossed into this bucket and floats around on the current. And you can have several buckets active at once. If you have R installed on your computer, you can start the console up one time, and you'll have it one session with a global electronic environment. And if you start the console up a second time on the same computer, it'll start up again, but it'll partition off a separate part of the memory. So you'll have R running twice, and the sessions will be unique from each other. They'll be separate buckets. Or if you have the console running, let's say you start the console and then you say, well, wait a minute, I want to use RStudio. So then you go and you start up RStudio. RStudio will call R again, separate from the session that's already running, and start yet another session, which has a different set of variables and a different set of files. So you need to be aware that you have a discrete, distinct workspace or session tied to starting up the console that holds all of your objects. R's object-oriented. So a variable, you create a variable, it will instantiate an object. You create a function, the function will be held somewhere described in a class of functions and as an object of that class, and it'll have characteristics and methods. Or a data set, you load a data set. You read a data set off of your disk, or you read a data set in from a package. Again, it will assign it to a class. It'll become an object.